Welcome back, and if you're new to the channel or new to this series, I am attempting to solve all 150 of the NeetCode 150 problems, and I'm doing this without looking at any of them beforehand. I used to be a software engineer. I studied computer science at uni, but I've not looked at data structures or algorithms in about 4 years, honestly. So I'm trying to relearn everything so I'm ready for interviews as well as just to brush up on my knowledge. So let's take a look at where I'm at. I've done 2 of the 150 problems, so a lot to go. I'm in the arrays and hashing section right now, and I'm going to do this next problem, which is labeled easy. It's called toSum. Let's see how it goes. All right, toSum. Given an array of integers called nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So let me read that again. Given an array of integers nums, so for example down here, and another integer, which they're calling target, okay, return indices of the two numbers such that they add up to target. I see, so in this one it should be 2 and 7, which are indices 0 and 1. Got it. Because 0, yeah, plus, great. So then this one here, we would do 2 and 4, which are indices 1 and 2. That makes sense. And here it's length 2, so it must be those two. Constraints. Nothing crazy here, I don't think. Only one valid answer exists. That's really interesting, and I think that makes the problem a bit easier, and I'll explain why in a little bit. And we may not use the same element twice. That's also good to know. And I'm assuming there's always an answer. Yeah, because it said only one valid answer exists. But that means there is always an answer, so that's also helpful. Okay, let me flip down to my whiteboard here and just think about this. So what I'm thinking that we could do is, let me write this first example out. The first idea that's jumping into my head is we know that there has to be two numbers that add up to the target. We know there's only one solution. And we know that we don't have to, we can stop as soon as we find it, basically, is what I'm saying. So I think we could do this perhaps with a set. And what I mean by that is, as we see a number, so say I have a set. Let me just think through this. Let me see if this is right. So let's say we have a set, and first we go to the first element in the array, which is a 2. So we add a 2 to the set, right? And then what's interesting is we know that the number we now want to potentially find is the same as target. So I'll make a note of this somewhere. Our goal is sort of to find target minus x, if that makes sense. So what I'm saying is, now that we've seen a 2, we know that if we find target minus 2, so in this case, 9 minus 2, which is 7, because we've seen a 2, we know that if we see a 7, we've solved it. And sure enough, later along in the array, we do in fact see a 7, which we could add to the set. But we know right at that point that we're done because we have a 2 and we have a 7. I guess interestingly, I also need to keep track of the index that each of these things are at. So I might need a dictionary instead of a set. And the reason I'm saying that is because with a dictionary, I can keep track of the key, which might be 2, and then the index that it was in the array, which was 0. That way I can have both of those bits of information. Right. So would this work? Will this solution work? I'll call this solution 1. Will that work? That way when we're iterating through, so let me split the 2 and the 7 up. So let me say 2, 11, 15, 7, like that. Once we see the 2, and I have my dictionary down here, we can add that there's a 2 at index 0. And then when we get to the next one, we see that we have 11. Oh, okay. What we want to do, so once we see any number, we want to check, yeah, like I was saying over here with, this is the key up here. Because, say I'm going through this, when I come to a number, so I come to 11 here, what I want to check is, do I have whatever the target is, which is 9. So target minus whatever on line, which in this case is 9 minus 11, which is -2. Is -2 in my set, or in my dictionary in this case? We look in our dictionary and we see that no, -2 is not there. So okay, I add 11, and that's at index 1. And then I keep going, I find, or I look and see 15 is target minus x, so is 9 minus 15, which is -6. Is that in the dictionary? No, it's not. So we can add 15 as an index 2. And then finally we get to 7, and we say, okay, I'll abbreviate this as t, is target minus x in the dictionary. That would be 9 minus 7, which is 2. And then we would say, oh, okay, 2 is in the dictionary, and it's at index 0. So now we know that we have this 7 that we just found at index 3, and this 2 we found earlier, which is at index 0. So then in this case, we could return 0 and 3, and we have it. And the beautiful thing about this solution is that it is O of n time, because we're processing this as we go through the array. We never have to stop and reiterate over it to check back on what we've seen. We can actually go at it in order. So that's excellent. Okay, I think I'm going to go with this as my solution. So let's flip back to the code here, and let's see if this time I can do it without looking at Stack Overflow. We'll see. My Python skills are a bit rusty, obviously. Right, so the first thing we want to do is set up a dictionary, right? So I will call it values. I'll set that equal to an empty dictionary. And then I want to iterate over the nums array. So then I could say for num and nums, just like that. And remember, back to my drawing, what I want to do is every time I see a number, I want to check that target minus that number if that's in the dictionary, right? So if, actually, I'll make it a variable so it's easier to understand. So call it a complement. The complement is equal to whatever the target is minus the number that we're currently considering. If that complement is in values, which means if it's in the dictionary, and remember this dictionary, what I'm going to store in it, this is going to have numbers as keys, index is the value. So if the complement, if the complement is in my dictionary, that means that my solution, I can just return at this point actually. So I can, remember I need to return a list of 2 integers, which are the 2 indices that add up to what I want. So I would just want to return an array of my dictionary evaluated at the complement. Like that. And then the second value in this would be the index of where we, so we've already, in this case, the complement is in the dictionary. So we know that if we look up the dictionary with the key of the complement, we're going to get the index that that complement was at. So that's correct. And then we just need the index of the number we're currently on. So I think the way I can do that, I can get the index for free if I use the handy enumerate function, which I believe takes any iterable, and in this case nums is a list, so it is iterable. And so this will spit out the index and the value, though I might have these reversed, and if I do have them reversed, I will go back and fix that, but that's an easy one to fix. So then we would return index. And then in the other case, so if we find the complement, we know that we're done. If we don't find the complement, we have to add the current value to the dictionary. So in this case, we would say values, the key is the num that we're on, and this is going to equal the index that we're at. So like that. Now, call me crazy, but this might be all we need. Let's run the test cases here. Okay, that's a good sign. So we're returning the right thing here. Yeah, we're returning the right thing for everything. I'm gonna go ahead and submit this. I'm feeling confident. Okay. I'm quite happy with that. So let's take a look here. Looks like this is about the fastest you can do it, like I was explaining earlier, O of n. And so I beat 62% of the other solutions, but I'm all the way on the left here, which I think is pretty good. Didn't do as well. Well, I guess around 50th percentile on memory, which is good, but it looks like you could have done this with a bit less. That's interesting. Yeah, very pleased with that solution. I think that's a very clean and concise way to write this one, and a good use of dictionaries. So thanks for watching, everyone. I will see you next time.